Hey, what's up, everybody? Welcome back to Hacking Smart Contracts for Fun and Profit. Today, we're going to be looking at challenge number 6, Selfie, from Damn Vulnerable Defi. So, a cool new lending pool has launched. It's now offering flash loans of DVT tokens. Wow. And it even includes a really fancy governance mechanism to control it. What could go wrong, right? You start with no DVT tokens in balance, and the pool has 1.5 million. Your objective? Take them all. Let's get into it. Okay, so we have our first contract here. Simple governance. Let's take a look. So at the top we have a struct here, governance action, which holds some data. We're scrolling down. We have an instance of the Damn Valuable Token snapshot. It's called governance token. Then we have a mapping here. We're just mapping a unit to the governance action with this struct right here. And then action counter, we have a delay action in seconds, 2 days. Okay, and then we have some events emitted. And that's it for the kind of variables and structs and stuff. So here we have in the constructor, we just require governance token address is not address 0, so governance token cannot be 0 address. Okay. And here we're just setting up, we're initializing the damn vulnerable token, and we have an action counter. We just set it up to be starting at 1. Okay, the first function, Q action. This is where we're gonna kind of dig into here. So here, basically, this we require has enough votes. Okay, so what does that mean? So here's a helper function to check if we have enough votes. So let's dive into this function here. What does this mean? So here we go. It's at the bottom here. Has enough votes. Okay. So we check for the balance of the account that's requesting the votes, and then we check to calculate half total supply of all the governance tokens here. And we do that by, we take the governance token, get total supply, and then we divide it by 2 to get 50%. And then we return balance greater than half total supply. So we're checking, basically we need more than half the total supply in order to vote. So part of our mission here is to get 50% of the tokens. Otherwise, we're not going to be able to pass this check. So somehow we're going to have to find a lot of tokens along the way, and then that's going to allow us to vote. So we have to find some tokens to pass this, and then we require this one, receiver cannot be this address. So cannot queue actions that affect governance, which makes sense. We can't basically. Oh, sorry. Let me go back on this too. Here on the inputs here, we have an address. We have this call data, this bytes call data, and then we just have a weigh amount. So basically, what we can do, we can put an address in here, but we can do it's similar to the last challenge where we can just place some arbitrary call data in here, and then we can execute it. So that's going to be kind of what we're going to do later. And then let's go down. So after we pass these 2 checks, action ID is going to be action counter. Okay. And then let's see, what do we have? We create an instance. This is the struct basically that we were looking at earlier. And then we're creating an instance of it, calling it action to queue. And then we're creating, it's equal to this array with our action ID here. Okay, and then we're just going to populate it. with some information, the receiver, the amount, the data, and then the timestamp. So we're just kind of creating this we're creating this action to queue. It says right here. And then after we kind of like we populate it with all this data that we want, then it's going to increment the action counter. Okay, and then it's going to admit that the action has been queued, and then we're going to return an action ID, which is uint 256. Okay, cool. So after we have an action queued, we're going to want to execute this. So how do we execute it? That's the next step. So we require can be executed with the action ID, which we just generated here, right? So how do we, let's look into this. This is another helper function here, can be executed. How do we know if this action can be executed? Let's find this function, can be executed. Okay, here it is right here. So we look, it returns a bool. So governance action memory action to execute, we're creating an instance of this struct with the array in the action ID, with the actions array and the action IDs. So we're just kind of bringing it up to look at which action we're trying to figure out if it can be executed here. And then we return action to be executed dot executed at is equal to 0. So what this line means right here is we look up here. Let's backtrack a little bit. What is it? Executed at, right? Okay, so here, let's see. Oh, here we go. So if we execute an action, we trigger this and we populate the executed at with the block timestamp. So this is going to basically timestamp when the action is executed, right? So this line right here, action to be executed at equal to 0, this will no longer equal 0 because we will be timestamped as soon as the action is executed. Okay, so we need this to be 0, and we also need the block timestamp minus the time at which the action was executed to be greater than or equal to the action delay in seconds. And we hard coded this action delay in seconds up here. Where is it? Here we go. Action delay. So it's 2 days basically. So we're basically checking to make sure there's no timestamp, and also that we are 2 days beyond which the original action has been proposed at. So you can't just queue an action and then execute it right away. Okay, so if we pass these checks, then we know it can be executed. Okay, let's go back. So here, if we can pass those 2 checks, we can pass this here. Next, we go on, we look, governance action, storage. We're creating another instance of this struct with the action ID in the array. And then we're looking at, we're populating it here, executed at, right? So when it gets executed, like I was saying before, we timestamp it. Next, we move on. We look at what data do we have. This is the arbitrary call data that we've inputted into the queued action, and then this is the weigh amount if we put any sort of money in with the contract, and we're just populating this data field here, and then we're emitting that an action has been executed with the action ID number and who sent it, and then that's it. So basically, these are really the two functions that we're trying to dig into here. We need to dig into this queue action. We need to figure out how to pass these checks. We need to get some tokens. And then also after we do all this, we need to execute the action. Okay, so that's it for that contract. The next contract, let's move on. We have this selfie pool here. So if we look into this selfie pool, let's see, it's basically we have an ERC20 instance here, token, simple governance. This is an instance of this contract here, simple governance, sorry. And then we have some events emitted. We have a modifier only governance. Okay, and then in our constructor, we initialize these. We initialize the token, and we initialize this other contract that we're going to be referencing. And then we have basically just a basic flash loan function. This is pretty much the same as what we've seen in the previous challenges. Nothing really too crazy here. This is the what we're going to be looking at here. And this receive tokens is this is where we're going to input some of our own logic in our own contract, because it's going to be looking for this function. Yeah, if it doesn't find it, it will trigger a fallback function, but we can just input this function into our own contract and then trigger our own logic from there. Okay, and then we just do a check to make sure the flash loan is paid back. Ooh, and this is an interesting function here. Drain all funds. That seems fun. But it looks like only governance can trigger this. So it's only this I guess it'd be, like a safety feature. If they feel like something's going wrong with the contract, we can, the governance can just empty the contract, and so they'll keep the treasury safe. But we might be able to manipulate that. Okay, so we'll come back to this one here. And let's just get into the coding. So I just want this token here to import that. I don't think I really need anything else. I mean, I guess I can go. I mean, I don't really need that. We need an interface for we just call it iGov for the governance contracts. And here, let's see, in here we're gonna need this queue action and returns. We're gonna need this. And I like to kind of separate these down onto different lines. It just makes it a bit easier to read and understand what's going on here. Okay, we need a queue action, and then we also need excuse me. We also need this execute. Okay, it's good for that. Next, we need a new interface. Let's call this one for the pool. It's called iPool. Keep it simple. So we're going to need this flash loan function. And I think that's it. Okay. So I think that's good. Set contract. Selfie attack. We need a couple variables up here. We need the Damn Vulnerable. This is going to be our token. We need the reference to the iGov. Let's call it gov. The pool. iPool. Let's call this pool. And what else do we need? Oh, we need the. We're going to need this. Action ID. We're gonna need, so we're gonna need this action ID. We'll see later, but basically, when you attach a public to these variables, you automatically get a free function, a free getter function if you attach public. So I can just call, say, this contract dot action ID, and it's gonna return me this. It's gonna return me this variable without having to create a whole helper function for it, which will be useful later on. Okay, let's see the constructor. The variable is gonna be token. iGov is going to be gov. Pool should be good. Then we'll initialize them. We'll say token. Okay. That looks good. Okay, let's get into the attack function. Attack, we're not going to need, we don't need any inputs for this, variables. We just need it to be external. And then first we need to get the pool balance. So we'll say token, the pool balance of the flash loan pool and then we're going to take a flash loan. Oh, sorry, I think I skipped over that part, I feel like. So how we're going to get 50% of the governance tokens is we're going to take a flash loan for it. And then we'll take a flash loan, and then we'll have a shit ton of tokens, and then we will create the queue. We will queue an action, and then repay the flash loan, basically. So we only need to temporarily hold some tokens in order to queue a governance action. Okay. So token dot balance of address of the pool. And then we will just take a flash loan. Say pool dot flash loan, and we want to borrow. Oops. Sorry, getting ahead of myself here. You went 256. Pool bow, and then we want the pool bow for the whole amount of the pool. Okay. So this, we're going to get a flash loan here we'll take whatever's in the pool, and then what's going to happen in this pool, this is where we're going to trigger this receive tokens. It's going to be looking for this receive tokens function. Okay. and just copy this. It's going to be function receive tokens external. Okay. So in here, this is where we're going to do the logic, and we're going to set up all of our voodoo. But really what we want to do, so after we have this flash loan, what we're going to want to do, we're going to want to take a snapshot. And then because it looks at your token balance at the last snapshot. So once we have a flash loan, we're going to take a snapshot. And then that's going to say, hey, this guy has a shit ton of governance tokens. Let him vote. Okay? So take a snapshot. And then after we have the snapshot, we're going to, let's see, did I actually, yes, I have the queue action. So we're going to do the queue action. And we're going to need to input all the receiver, the call data, the weigh amount. Okay. So we're going to queue the action next. And so when we call this, it's going to return us, sorry, where is it? So it's going to, oh, sorry, right here. It's going to return a uint 256, right? So this is where we're going to store this in the action ID. So later we can reference that as an action ID. I don't actually want this. I spelt this wrong. I don't want a big D, I want a little d. There we go. So we're going to store it, the number, we're going to return the uint, and that uint is going to be our action ID, which we'll use to execute the action. So we'll just say action ID is equal to gov.queueAction. And here it shows us the receiver data. So receiver is going to be the pool, because we want to queue the action on the pool. And then here we enter our arbitrary call data, right? So what we want to do here is execute this drain all funds. This is what we want right here. We want to so we're targeting the pool, and we're looking to execute this drain all funds function here. So we do that like we did before. We do an ABI encode with signature. We do the drain all funds like so. And the address we're looking for is going to be transaction.origin, right? Because if we say like message.sender, that's going to be the governance contract. But really, we're going to trigger it, and that's going to be the origin of the transaction. That's where we want to drain all funds to. And weigh amount, we're just going to go 0. So here, once again, it's going to separate this down onto different lines, makes it easier to read. Cool. So now we've taken a snapshot, we've triggered a queue action function, and the last thing we're going to want to do in here in this receive tokens function is repay the flash loan. So receive tokens, uint amount here. We're just going to say amount, and then this is going to be amount here. Cool. That looks good. That looks good. So right here we're just repay flash loan. Okay, so after we repay the flash loan, we can, back in our attack function, we should pass that, and then back in our attack we can just transfer tokens to attacker EOA. So here we can just say, so at this point, actually, sorry, we're not gonna, it's not going to, we still have not executed the queued actions at this point. So I think what we need to do here at this point, because we need to wait, after we've queued an action, we need to wait 2 days. So we're gonna, queue the action, then we're gonna fast forward in time through the magic of the Ethereum EVM, and then we're going to execute the action. So we need a function to just execute. We don't need anything in here. Just call it external. And here we want to say gov.execute action, and we put in the action ID. Perfect. So this should be good. Let me just check over. Let me see what we have. Okay, looks good. Okay, so to save a little time, speed things up here, I already put in, I put in the code for the test here. So I want to make sure I do it. Test, pool, governance. Token, oh, I did it a little backwards here. Token, governance, pool. Token, so to switch these two. So token, governance, and then pool's the last one. Okay. So basically, yeah, this is the same as the other challenges here. We just initialized the contract and then deployed it all in one function here. And then we called the attack function, which will queue the action up, and then we fast forward in time here. We fast forward in time 2 days. How this works is, so it goes 2 days. So this is all in seconds, right? So we have to add up how many seconds are in 2 days, right? So actually, if you go backwards here, so 60 seconds times 60 minutes times 24 hours times 2 days. That will give us the amount of seconds that's in 2 days. And then we just increase, so this is increasing the EVM by 2 days. And then after that, we're going to be able to execute. Okay, let's try it out. Yarn run. What is this one called? Selfie. Okay. Waiting. Oh, and we passed. All right, that's it for the selfie challenge. Thanks for tuning in, and we will check you out next time.